Hi guys, today we are going to view the basic recommendation system that we are looking for. Do you ever wonder Amazon or Flipkart or any shopping app does recommend I'm going to first I'm going to give an example for that. Just an example for I'm going to buy this shirt. For this, here the Amazon will give the proper introduction and the proper detail of the product, and it even suggests some basic similar from buy it with. That means that here the customer is bought this product and is also bought another product that will combine together. It is this one. That means Amazon deal is comparable to the customer's reviews, and it is able to recommend the products to be like here at last here similar like related products with something that will recommend that products or any stuff to the customers the viewing from this category. Here products related to this item, and that means here I'm choosing like a jacket. For this, here we the related product should be only jackets, right? There's no majority of them the jackets, a few of them were shirts, and we will become at last, we can see the outmost layer. For suppose I'm going to write another name that she is only containing t-shirts or electronic item. Just completely change the option. Okay, here we can clearly see that it did take some loading time. Right for okay. We can clearly see after the end of the review, it is even recommended some basic mobiles. So here and it is given compatible with the comparison category. That means the customer should be rated from display or anything, camera, front camera, or charging from that. It is able to calculate out that. And here, here the product should be like here some of the inspired by it even recommended some related to phones. Majority of them should be phones. This is the earlier history of my products system. Like earlier, I discovered, I checked this Insta, right? Okay, is this explanation were good enough for you already? Let's get into the writing part. Let's get into the coding part. How this going to be work? For this, I'm going to install some libraries that will depend on Keras. We no need to download any dataset or anything. Here, I'm just extracting the library and extracting the dataset from the Keras that containing the 60,000 photographs, 60,000 product items. That means it even containing some t-shirts, trousers, or anything of in particular. Here, this why. These products to be like in this category. They are 60,000 photos are there. Okay, I'm just first I'm going to load the most portable and the load the data set. I'm going to print the shape of the data set here 60,000 and it's in the shape. That means the shape of the it is going to be rows. How many labels, how many photos are there, and it is 60,000 and the rows, and that means width, like width, width. Here in this I'm going to extract the few libraries that will come out in the from a gray color. They will come out in the only products that we all should be right now. That means here I'm going to plot some or graph containing containing only 10 photos. That is 1 to 10. That means it means 9 photos that will containing the photos of the dataset in a plot here. Even some I granted some indicating values. That means the ratio. Yesterday I discussed some 60,000, 28, 28 here. 60,000 photographs and the 28, 28. That means length, breadth. Okay. Next, I'm going to expand the category. That means we are having a like a data set, but no one can understand, can really know that how every photo is exactly the same as the same photo. That in every photo that has the same size, right? First, we are going to extract the photos containing on those photos. For that, I'm going to fit the data set that will contain only the same size of photographs. Okay, for that, I'm going to write a definition. That means I'm going to write a function that will and modify the function that is according to that volume. Here, I'm going to use the CNN algorithm for that. That means I'm going to give a perfect, really good example for that. For this, I'm going to click right into my GitHub for the understanding purpose. Okay, I'm going to date in that part. Okay, I'm like this is the simplest function first, and I'm going to modify in the two real-time function for each and every extracting how this is going to be work right now. Okay, earlier I said first I'm going to load the data set. First, I'm going to import the libraries that I wanted. TensorFlow for extracting the libraries and plot the values. And then NumPy is for the array plotting. That means here we can clearly see that the array of the photos. That means the 60,000 photos. It is arranged in an array. That means we are going to add X. Like we are going to extract the image by. We are going to extract the image by indexes. That means here indexes, right? That's why I'm going to go with that. Okay. Next, I'm going to import the libraries and I'm going to load the data set and I'm going to divide the data set into trained data set and test data sets. First, I'm going to Okay, I'm going to use the fashionmints.com designator to drop in replacement of the classic mints dataset often uses the hello world of machine learning programs for computer vision techniques. Computer vision. For earlier, I said we use CNN algorithm for that and that means see a computer vision algorithm. The means dataset contains handwritten like 0 to 160,000 60,000 photographs. Okay. Okay. Yeah, I said retraining which is arrays. That means here containing the arrays of that model used to learn. The model is to learn by the indication of this, this is one sneaker, right? For that, this is supposed to be sneaker. That means that we are going to learning the model by using this columns. That means he is these keys. Okay, and yeah, well, that means we are going to put it in an array. That means we are going to indicate the every indexes by this key. Okay, let's explore the data. But if we are going to print the shape of the data, that means the shape of the data is 60,000 and for 20 days earlier I said the length of the data is 60,000. And we are going to, this is for train and this is for test travels. And the next we are going to plot some one plot. We are going to plot some sample techniques. The data must contain pre-processed for like the training the network. If you increase the first image, that means I'm going to print the first image of how it is going to be calculated. Here, this is supposed to be sure, right? I'm mentioning the points to be learned the algorithm in the model by by using some indications that is this shape supposed to be shoe. That means here it is look like a shoe. That means it is a shoe category. I'm going to model that, letting the model by using this only for one photo. Okay, that means the data must be processed. That means we are going to do the before the training of the network. If you enter first image, you will see the pixel values. This is the pixel values of this data. That means here it is one dot, right? This is one dot, this is one pixel, this is one pixel. How the pixel going to see the the pixel model? That means how the pixel is look like to learn the algorithm for that. The next thing, see the values of 0 to 1 to 10. See the values of 0 to 1 to 10 before feeding them to neural network. it is going to look like 2. So divide the values by 255. That means we are going to divide by 2. That means 0, it means no, like a no future, it's going to be they no indication that we did. That means here no indication. That means no future that need done. Even in this part, they have some feature that we are going to extract it. To verify that data set format, and you are ready to build your training data, display some 25 images from the data set. The display of class name below each image. Here we're going to extract like it. I'm going to append this column to the each and every image, and I'm going to plot some images like that one. Here we can clearly see that this is supposed to be the user address, and supposed to be anything like that you want. I'm going to print some plot between the row stresses or something features to relearn the algorithm for depending on the feeding of the pixels neural network. That means okay, neural network. I'm going to build the model to recognize these features. I'm going to give the next exact output of the recommendation products like this one. Like me, I'm going to see in the jacket, right? For that, I'm going to it is going to recommend some another jackets, but some of them have some t-shirts. Let's look like this. Okay. And here I'm going to use some KRS library for the building a neural network, that means configuring layers to model. That means we are going to each recognize indicate the each layer by this feature, right? Okay, as for setup of the basic building block of neural layer is a layer. That means layer extract representations from the data to feed into them. Hopefully, those representations are meaningful to the problem to hand. Most of deep learning consists of chaining together simply layers. Most of them like a simply dense layers. That means here we are going to activate some. Here I'm going to add a simply dense layer. That means we are going to ReLU function for that. We are going to use a ReLU function for extracting that values. First, the first layer of that here pairs of layers of flattened. That means here the two-dimensional array of 28 by 28 pixels is if to a one-dimensional array for 28 to 50. That means here this is supposed to be length, this is supposed to be length. This is only having two arrays. I'm going to transform into one-dimensional array. For that, I'm going to use a player start flatten. And after that, the pixels are flattened. And that means whether networking is a sequence of two. That means these are densely connected or fully connected or neural networks. We are going to connect it into neural networks for extracting the values to be between them. The second and last more layer of the velocity array, that means each node contains a score that indicates the current image belongs to one of these 10 classes. That means we are going to recommend some one image based on one image. Here that is going to be recommend some other images according to that. And here the next thing, I do is optimize the data set, and we're going to each one we're going to accelerate the loss and the accuracy of that model. Here the loss is supposed to be only 49%, and the here the loss is like only 39%. But the accuracy rate of the model building it was 82%, and it is the 3 second report supposed to be 86%. That's nice. And I'm going to save the data set into save the dataset and going to append the dataset into train and test tables for that. Here I'm going to like a cleaning and data processing, and we're going to show the plot how the one image and how the dataset should be like. And I'm going to after that cleaning and data pre-processing, the building a model and after the building a model, we are going to append the dataset into the model for extracting the features. For that, I'm going to exercise, and this is the function that I will use. Okay. First, we are building the model successfully. The next thing we're gonna do is train the model first, and then to train the model according to the accuracy and that epoxy between them. feeding the training data to the model in this example, like the training data is the training images and training. The model learns to associate the images by extracting them and manually. We're going to check each and every containing indexes, and we are going to compare the features tokens between the photos. That means the features, like the data set. The next thing I'm going to do is the accuracy of the data set. That means it is supposed to be 86% earlier I mentioned, right? Okay. The next thing, it turned out to be great. The next thing is the model has to be written. The whole model is going to, we are done with the model learning. And the next thing we are going to do after finally, we are going to evaluate the predictions between the models to be taken up by me. That means we are going to evaluate the result of that. For that, like earlier I said, this is the same code as the this one, but here some basic introduction between them, some betweens like I'm going to give like indexes. For shoe, it is supposed to be this index. That means here it is only categorized by only 9. That means here going to get 9. And for shirt is going to be look like a 4. That means I'm going to give only 5 is the rating that is giving to. It is look like a show, right? 1, 2, 3, 4, 5, and 6, 7, 8, 9. It is look like a show. It look like a show. That it is the image of 10. It is look like more exactly the 4. That means how 4 is supposed to be the trace. That means here like comparing each and every feature between them and giving probability result. The model has always not be good, right? Here we can perfectly seen, right? Earlier we select some jackets, but it even some recommends some t-shirts or like combos or anything. We the model is not giving the exact answer, the exact giving the accuracy of that model. Some flaws between them, but our model should be right. It is supposed to be having 86%. That is turned out to be, that's a great possibility. And they're going to each and every model for that. That means shoe it is containing only the it is look like a show. That means I'm giving a 9. That it is supposed to be shoe. That means if we have it is look like a top. That means is something like look like a top of any the shirt. It is going to category into 4 majority, and 2 is the most category that will be recognized as shirt, right? I'm go here this is only for one photo and this is only for one photo. What about the remaining photos? I'm going to give, and it means we're going to give each and every photo for giving a some value rather. Yeah, earlier this is 2 exactly. 2 is perfectly matched with the t-shirt, right? That's why the result is high here, 100% full over. Here, this is only containing only percent 96, but it means it is going to category of the shoe, but it is going to look like a scatter. That's the recommendation. But this every model has to like some flaws with them. Not every model is perfect, right? That's why it's recommend some one between them. It's yeah, it looks like a browser. That means it is one browser. That means a browser. That means it is giving one value here. 10 with 10. It is look like a so. So it giving one value. I'm going to each and every follow for that. Okay, after that, I'm going to give an like some name. After something, I'm going to give like a 9. I'm going to train that model. Okay, run anyway. Sorry, some with them. Some give me some time, guys. I will explain to you everything. Sorry. So I'm going to extract for every possibility. That means we are going to access every other possibility for that. Okay, it's corrected. It is run correctly. Okay, it is loading. After loading, I'm going to open the columns. It's going to append the columns and the shape, this shape. Okay, okay, okay. And the next thing, it is great. Plotting the image of that one photo, and I'm going to test the accuracy, and I'm going to append the other photos for that. Now for this, continuing photo, and training that epoxy. Oh, saying the count is not enough, right? Thing, no problem. Okay, we're going to correct that right now. Where is there? Where is there? Where is there? Where is there? Okay. After plotting the village, that means after plotting the images, so basic way is right, and after this, we don't do not optimizing the accuracy, right? That is it now. Saying it's not closed, but means we only having only one drive. That's why it's saying that. Okay, it corrected. And I'm going to save that model. Epoxy writing, it means building the epoxy for every model. For that, which is supposed to be concept like something like it's loading. We are correcting there. That's nice. Okay, these needs be like it's taking some time to load. The result happens sometime. That means the epoxy should be done by every 60,000 photos, right? That way it's supposed to be so like we're going to 3, 2, 1. Here the accuracy are mentioned, the loss of each and photo of the mentioned. That means we are going to categorize this into 10 categories, right? 0 to 10 categories. That's why it is going to epoxy. We are going to use some epoxy to mean actually recommend some products related to the stuff we are going to use it in the right categories. That's why it is taking some time to load the 50,000 categories. Okay, done it, done it. Then epoxies. Okay, okay. 9. Okay, this is the last one. It's the last one. It's the last one. It's the last one. Done already? Done. Okay, done. Done. Finished. Finished. Labels. How many labels it containing? Here, it is only having only 10 labels. But earlier, the test labels are how many? 10,000. It is going to categorize into only 9 categories is after that. Okay, the next thing I'm gonna do is print some values according to that. And after this, another photo and all the photos of the containing 10 categories. That's nice. The next thing supposed to be 9 of containing of life, only it is containing on dash something. That means we're going to expand this into one empty array, and we're going to create this image accuracy. And I'm going to plot them to check the image. That means It is like I'm going to give a 9. 9 it means sorry 1, 2, 3, 9. That means it's going to be scanned. Okay, so it's like a yeah, yeah. This one, like this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Something repeated like the sneakers is perfectly right. And the plotting of the sneakers, it is going to again it is where's the number of that image of containing is going to be 4, 2, 3, 4. Thank you for doing this. I hope you learn something. This is the code is actually in my GitHub for accessing. Those who will learn that's how running their own system or recommend system for that. This is the code I've written in a good week for everybody. You download and download from a recovery and use the code to run your own computer to see the output or in your screen or in your computer. Thank you guys. Thank you. Thank you guys viewing this. Signing off.